In this video, I want to talk about functions. So when we talk about functions, depending on where you are right now in your math, just if you're just kind of learning about functions, really just think of them as an equation, okay? For instance, like what I have here, like if you have y equals 3x plus 7 or y equals 2x squared plus 1, those are equations, right? So they're also functions, okay? Now, there's going to be some differences, but for right now, all you need to do is think of functions as just a fancy name for equations. Okay, adding to that though, when we have functions, we'll do what we call function notation. And so I'll take the same equations right here that I had, and I'm going to put them into this function notation. So for instance, down here, I really wrote the same 3x plus 7, but I wrote f parentheses x parentheses. Now I'm going to read that as f of, I'm going to say of, and then I'm going to say x, f of x. That's how you read this, okay? And then that's equal to 3x plus 7. And then over here, I took this y equals 2x squared. What if I write that? I wrote y equals 3x plus 7 in your equation form that you're used to. And then I wanted to plot some points on there. For instance, let's say I did the old t-chart where you say, okay, when x equals, what does y equal? So then I go ahead and say, okay, when x equals a -2, a -1, a 0, a 1, or a 2, well, what do I do when I'm asking that? Of course, I have to plug in to the x value right here, each of those numbers. So, for instance, if I want to get their -2, I'm going to go 3, and then I'm going to replace the x with a -2, so 3 times -2, and then add 7. -6 plus 7, that would be 1. Plugging in, going for the -1, I'm going to plug that in. I'll get 3, -1 plus 7, and I'm going to get a 4. Plugging in the 0, 3 and 0 plus 7, that's going to be a 7. Plugging in 1, see the patterns going up here. We got a 10, and then this one is going to be 13. So that's what you're used to doing. Okay, so functions, what I would do instead, so if someone asks you, if someone instead of making the t-chart, if the equation, if the problem said, okay, here's my equation, it's y equals 3x plus 7, and then the teacher says, what is x when, let's say, what is, we're going to go back, what is y when x is 4? Okay, so there's a sentence that I have to write out if I'm asking the question, what is y when x is 4? Okay, now, of course, would then go y equals 3 times 4 plus 7, 12 and 7, so 19. No problem, right? Well, with function notation, instead of writing y equals 3x plus 7, I will have written this as, I used the letter f. You can use any letter you want here. F of x equals 3x plus 7. Now, instead of having to write all this long sentence out, what is y when x is 4? The person asking you or whatever could just say this, f of 4, question mark. This means that here was my function up here, 3x plus 7, and whatever I put in parentheses here, see here's the x, whatever I replace the x with, that tells me that I'm going to be putting this number in for the 4, or for the x right here. All right, so let's think of another one. What if I said, same equation, and I said, someone said, okay, and this is f of x equals, I'll do a different one, 2x minus 4. And then the question says just this, f of -1, right? So I don't have to say all these words. What is y when x is -1? It'd just be this. Then you know you're going to take your equation and you're going to substitute for the x, you're going to put in -1. And then you're just going to give the answer to that, which is -6. So f of -1, meaning when x is -1, I get an answer of 6. So that's one thing when you're dealing with function notation, is that it's much shorter when you have to come out with valuations. And it's really not that bad once you get the hang of it. Now I'm going to write, I have another function here, f of x equals 2x minus 1. And I'm going to ask for, okay, what is this? What is f of x plus 3? Now, remember when I had something like f, I took the f value of the function and I said, all right, what is f of -1? You knew that you had to replace the x with a -1. So in this case, I would have done 2 times -1 minus 1. And I would have evaluated that, a -3, -3. Well, the same rules apply here. The same rules apply when I have this. I'm just going to write my function part again, the 2, and I'm going to put parentheses instead of that x. And since it wants me to replace it with an x plus 3, I will do x plus 3 right there. Then I have to write the rest of the function, which is -1. Then we're going to talk about, you're going to be distributing the 2 times the x plus 2 times the 3. So you get a 2x plus 6, and then we still have this -1, and this would simplify to 2x plus 5. So I get an expression, but when I plugged in that x plus 3, this function up here changed to this. So think about if you had back when you just did this notation, y equals 2x minus 1, and then they said find y when the x equals x plus 3. So again, I would have to write this all out, and the idea is that when I just say f x plus 3, I know I'm going to plug whatever's in there into the x. Okay, let me take the same thing. If I have x of, let's say this time it's a 2x squared minus 4, and then it says I want f of x plus 1. Okay, you have to be careful here because what I'm doing is I'm plugging this x plus 1 right here where I have this x. So I'm going to rewrite this function right here. I'm going to write the 2. I'm going to leave a parentheses here. I'm going to have to square that parentheses just like here. I will have the -4 at the end. And so what I'm supposed to be plugging in now is the x plus 1 that goes right there. Now be very careful here because you got to remember when you have a binomial, this is a binomial in here, meaning 2 terms. It's an x plus a 1. When you have that squared, you're going to have to multiply that parentheses times itself twice. Then you get this where you do sort of a double distribute. Some people call it FOIL method, where I'm going to take this x in front, multiply it times that x. That I get an x squared. You do the plus x here, and then this 1 times x here. I get plus 1x and another 1x. And then the very last ones, I have a 1 times the 1. I get a plus 1. So I get the x squared plus 2x plus 1. All right, so this came out to be a 2, and this right here, the x plus 1 squared, came out to be the x squared plus a 2x plus 1, and this -4 is still there. Then I have to distribute this 2 into the parentheses, all of those. So you end up getting a 2x squared plus a 4x plus a 2, and then there's a -4 on the end. And then I can combine the like terms there with the 2 minus 4, and you're going to get a -2. So that's how you use function notation, and it's really a notation thing, shorter than writing out the question, and so you want to get used to doing that. But once you get used to that, they start to become pretty smooth. You remember you're going to be plugging in for wherever there's an x. Now, I want to go a little bit further and say, what if we had something that said we have f of x and it equals, let's say we have x squared, and then we have another x, but it's just x to the first, and then -2. And then we want to know, someone says, okay, what is f of, let's say we have x minus 2. All right? You know what that means, is that everywhere I have an x, I'm going to replace it with this x minus 2. So right here, let's start by making this, instead of the x squared, I'm going to just leave a space here for now and put this squared. Then I'm going to write plus 7, and then instead of writing the x, let's put a little parentheses here to replace the x, and then I still have a -2. Now, what am I putting in the parentheses? Well, it asked me to put in x minus 2, so I'm going to put it for this one and then for this one. Now we're just simplifying it. This right here, you have to multiply the x minus 2 times itself, which is going to come out to be an x squared. You got a -2x, then you got another -2x, and then you've got plus 4. That'll simplify to x squared, take away 4x plus a 4. Now this right up here, we're going to distribute the 7 into the x and the -2. So we're going to have plus 7x minus 14, and then we still have the minus 2 on the end. So now we're going to gather like terms in here, and so what are we going to have? We're going to have x squared. That's going to be the only squared term. We've got a minus 4x, and we've got a plus 7x. It's your plus 3x. A plus 4, minus 14 is minus 10, minus 2 more is minus 12. And so I have just found where I'm just plugging in this x minus 2 wherever you see an x value.